So hi, I'm Pavandeep Kalra, and this is Ilan Ryder. I'm a director of data science in Microsoft's data group, which is basically the engineering team that's creating all of the machine learning, advanced analytics software that we've been launching very rapidly over the last couple of years. So I want to set some context into why we are doing this session and tell you a little bit about what my team does, and then we'll get into the rest of the session. So my team is basically a team of data scientists and machine learning experts, analysts, who really work very, very closely with our strategic customers, partners, ISVs, to help them land advanced analytics solutions on the cloud, on-premise, on hybrid scenarios. So over the last few years, we worked with hundreds of customers in making that happen. So I want to share some of the best practices as we've built the team up into experts in all sorts of areas in forecasting and computer vision and text mining and so on. Also share how we find that certain pilots tend to fail and certain pilots tend to become quite successful. So there are some learnings, I think, which are very useful as we've done this kind of work. So before I start actually talking about that stuff, and Ilan's going to actually talk more about those learnings, but I want to actually talk about a few other things. So what you're going to get out of this session is first we're going to talk about why, which is basically the trends that are going on in the industry right now around advanced analytics, what's going on in the industry. What is the offering that Microsoft has around advanced analytics? We've actually put out a lot of stuff over the last 2 years, and I'll touch on what some of that stuff is. And then we are actually going to talk about the advanced analytics solution process, which is how we run our data science teams, how do we engage with customers, how do we really engage with sometimes 20 different pilots in advanced analytics in very sophisticated scenarios simultaneously, and what makes some pilots succeed and some pilots fail, and which Ilan, who's one of our senior principal leads on the team, is actually going to talk about. So let's get started. Before I start, how many of you guys would say you do data science, advanced analytics on a day-to-day basis? So I have a sense of the room. Okay. So this is a quotation by Satya, which he made when Satya became the CEO of Microsoft about 2 years ago. And I find this very, very useful. He was not talking about, this was not a Microsoft strategy. He wasn't talking about my team in particular, which though it seems like it's really hitting what my team does. But he was really talking about the trend that's actually happening in the industry over the next decade or so. And what he says is, I believe over the next decade, computing will become even more ubiquitous and intelligence will become ambient. This will be made possible by an ever-growing network of connected devices, incredible computing capacity from the cloud, insights from big data, and intelligence from machine learning. So it's a statement I find really quite on mark in a lot of the work that's actually happening right now. So before we get into some of the trends, let's look at one of the customers we worked with and look at the transformation that's starting to happen here. I think we got to go back. Let's click.
The U.S. healthcare system is challenged by the task to deliver exceptional, personalized care at a lower cost. Despite spending nearly 1/5 of our gross domestic product on healthcare, we struggle to meet this goal. Financial pressures on care providers are increasing. This isn't sustainable. So how can we deliver high-quality, personalized care that patients deserve, given the cost pressures we face? At Dartmouth-Hitchcock, we've created ImagineCare, a new cloud-based solution built on Cortana Analytics Suite and Microsoft Dynamics that enables providers to help patients achieve better health. With the help of Microsoft, Dartmouth-Hitchcock is building a technology platform to serve healthcare organizations and patients across the country, setting a new standard for personalized care. Now, using machine intelligence, providers can develop a care plan that's unique to each patient. We can monitor patients from their homes, where data is collected from devices and sent to the cloud, to ImagineCare's 24/7 contact center, where registered nurses continually monitor a patient's health status and potentially serious trends.
Cortana, summarize health status for Ben Andrews.
Ben Andrews' weight has increased more than 2 pounds in the last 24 hours. Please review the home diuresis protocol prescribed by Dr. Phillips.
Patients get reminders and encouragement and dynamic updates to their care plans, improving their health, helping them avoid unnecessary trips to the emergency room and reducing the cost of care. With support from loved ones and real-time interventions, there is less likelihood of readmission. With Cortana Analytics Suite and Microsoft Dynamics, we're transforming the way healthcare is delivered today, improving patient outcomes, reducing costs, and offering an unprecedented level of personalized care.
Yep. So this is one example, I think, of healthcare transformation that's going on. But really, in all the industries that we're working with right now, in energy, in pharmaceuticals, in financials, in automotive, really we are seeing a really big transformation starting to happen. And it's all dependent, obviously, on what that industry is, but a lot of things happening in all those industries. So why is this all happening, right? So what is the trends that is accelerating this kind of pace and transforming the business processes that people are trying to do? So a few things are going on. One is, I think everyone knows there's a ton of data coming in. I don't even know the exact number. I think the amount of data that was collected up until 2004 throughout the mankind, now I think every 2 days we collect that much, in the way it's getting collected. So there's a ton of data coming over. But really, that's interesting, but I think even more interesting is the fact that if you look in this graph, I don't have the y-axis here, but if you look in the graph, what's going on is that the green portion there is the data on the cloud, which is basically connected data. So this has an IP address. And that is really starting to take over now. And that was not the case even if you look back in 2010, right? That's really not the case. But over the next 10 years, everything that's getting, all the data is getting generated through your mobile devices, through the cloud, through all the other kind of IoT devices, is really coming into the cloud in a massive way. And that's really starting to create this one trend which is happening. The second trend that's actually happening is that the compute that's out there has grown exponentially, even faster than exponentially. So between 1940 and 1980, there was a 1 million-fold increase in compute. And if you look at the curve of the way compute grows, it's actually growing faster than exponential. So on a log scale, a linear line would be exponential growth. It's growing faster than a linear line. So computer is growing at a very dramatic pace. So the combination of the huge amounts of data, connected data with IP addresses, and a lot of compute is causing this kind of disruption, which I think is really now creating this kind of a big change in the industry. I mean, machine learning data science has been around for a while, for the last 20 years. Neural nets and many other machine learning things have been going on for a while, but this is the disruption that's happening now, is being caused by these trends. So how do you kind of think about, let me just build up this slide quickly here first. So how do you want to think about advanced analytics? And I think some of you guys might be familiar with the points I make in the slide, but I want to actually really point out one big thing in the slide. So, I mean, if you think about the most basic thing is, you have data coming in, you can create static reports around it, right? That's your bottom layer. You can explore and figure out why are things happening. This is your exploratory stuff that you can do with Power BI quite a bit. If you start to get a little bit more sophisticated into machine learning, you can make predictive models and say, why is it happening, or what will happen in your predictive models. And finally, you can make it prescriptive and say, what are the recommendations so that, in fact, it's fully automated. Your whole decision-making process becomes automated. Now, I don't want to belabor this slide too much, but the one point I do want to make is that the data by itself is useless. Really, what you are trying to do is the actionability around it. If you don't get into that actionability, eventually, it's kind of a useless point, right? So there's no dearth of data. There's zettabytes of data every day that's coming out of those devices. But really, there is a really dearth of intelligent actions which are happening with it. And the more you can actually tie your business processes into the recommendations that are happening, into an actionable thing in your business process, the more useful this is. Otherwise, it's somewhat useless. So that's kind of the trending that's going on. I want to talk a little bit about Microsoft's platform vision around how we think about advanced analytics. So the key statement around transforming your data into intelligent action is pretty critical into how we actually are building this whole platform out. So getting the data is very interesting. Getting to the action is where the problem starts happening. And how do we make that happen in a quick fashion? So what are the key principles that we are going after? One of the key principles is any data. Anything relational, non-relational, text, images, video, audio, time series, we want to handle everything, right? We don't there's no data that we don't want to be able to handle. Any analytics. So there's all sorts of analytics. You can do machine learning, you can do ETL, you can do transaction processing, you can do operational analytics, you can do perceptual intelligence like facial, speech, you can do visualization, right? We want to be able to do all of that stuff. We want to handle at any scale. Small data, big data, petabyte, zettabyte scale. So we want to be able to take the whole thing, right? We want to do all kinds of scenarios, batch, streaming, interactive, really, because there's all kinds of scenarios which require all of this stuff. Any location. Cloud is great, but a lot of the customers are still on-premise, right? And even if you look back, if you look at research studies in the next 10 years, even though the on-premise software is declining and the cloud is growing, there's still about 60 to 70% of the stuff is on-prem. So you want to make sure that everything we're doing actually can work on-prem, cloud, and in hybrid scenarios between all of that. And any source. So not only do you want best of the enterprise grade, like security, scale, and so on, but we also want to integrate open source into our products. And that's a pretty core principle in most of the stuff that's happening right now in Microsoft. So where are the investments happening on advanced analytics for Microsoft? There are three basic investments going on. The first one is what we're calling the Cortana Analytics Suite. This is the advanced analytics suite on the cloud that we have. We're basically building all the pillars in it for data ingestion, data storage, data analytics, visualization, perceptual intelligence, all on the cloud. I'll get into a little bit more detail in the next slide around the exact specifics around Cortana Analytics, but that's a major push that's happening right now for one of our big investments. The second is on the SQL Server 2016 launch that happened recently. We started to bring analytics directly into our databases. So in a lot of cloud-related stuff, you actually have to have the data on the cloud. For people who are running on-premise databases, to take the data out of the databases and put it into a place where you can actually do analytics can be a little bit hard, because if your scale is huge, then you are going to have problems moving that much data in. So we're bringing the analytics directly in by embedding R, for example, directly into SQL Server and running at scale within SQL Server 2016. And that's basically some of the innovation that are happening is we are integrating some of the work that we acquired Revolution Analytics last year, and we're taking some of those assets around high performance R scaling, and we're bringing that directly into SQL Server. And then we also have Microsoft R Server, which enables you to run high scale analytics on multiple environments like Hadoop and Teradata. So three major pushes on investment that are going on. So just a quick, I don't want to spend too much time here, but I want to give a sense to the folks in the room, what's the investment that's happening on Cortana Analytics Suite here. So the first thing that's going on is that you have to be able to bring all this data into the cloud. And we are creating products which enable you to stream data at a very high clip, so almost a gigasecond or higher. And you have the ability to orchestrate all of this into complex workflows, be able to catalog all this, discover all this data. So there are products in the suite which enable you to ingest all this and do a lot of information management on this data so you can actually work with it. Now you need to be able to store all of this data in large scale, and we have the SQL Data Warehouse, which can go into petabyte scale for relational data. And then we also have the Azure Data Lake, which is basically unstructured and structured data in exabyte scale. So large scale data processing systems on the cloud that do both relational as well as non-relational data storage. The third pillar here is machine learning analytics. So once you have all the data, you are able to create workflows around it. You want to do something more interesting with machine learning, recommendations, predictive models, and we have a variety of ways you can do that. You have Azure Machine Learning, which is basically a visual software on the cloud where you can go in and build your experiments by drag and dropping modules and operationalize those as APIs directly on the cloud. A very easy way to get into machine learning if you haven't spent a lot of time doing machine learning earlier. Then there's more traditional open source stuff like Hadoop and Spark, Storm, HBase, which is all on the cloud in a managed environment. So you don't actually have to create your own clusters or own topology, manage it. It's all kind of in a managed environment for you. We have the Azure Data Lake Analytics, which is basically large-scale data warehouse, exabyte scale. You can actually process data on it in very easy fashion in a language called USQL, very similar to the SQL language, and do large-scale data processing on the storage that's in the cloud. And then we have Stream Analytics, which enable you to do analytics on streaming data coming in. So if you are trying to get IoT scenarios where you have data streaming in from Internet of Things devices, then you can actually look at the stream in very simple query-like language in SQL, basically, very similar to SQL. You can actually do aggregations on the data that's streaming in, and actually do create dashboards with aggregations or other analytics directly out of the streaming data. So very easy to use analytics through the Azure Stream Analytics. And then finally, I think we have, as we get the data out, there's the front end layer is we're also publishing baked APIs now in the marketplace, which basically enable you to just integrate an API and do things like facial recognition, speech, recommendations, churn scenarios, without actually having to do any machine learning. And then finally, we have Power BI. So you have the visualization, and it's fully integrated with Cortana, which is the personal digital assistant. So you can actually integrate and actually ask questions like in the video that we were showing there. So this is kind of the vision of the suite. But again, the key thing is how do you go from data to intelligence to action in a very quick fashion, and that's what we are optimizing the whole flow for Cortana on. Quickly wanted to mention the APIs I was just saying here. There's a ton of APIs, and thing to think about in advanced analytics is how many of you guys today, I kind of give this as an example. How many of you guys today wear clothes by going to a tailor, right? How many people go to a tailor today, right? 40 years ago, a lot of people used to go to tailors. So that's what's happening today. A lot of people are doing very custom, up until 10 years ago, or even, till I would say pretty imminently, people were doing very custom APIs. My thinking is that in about a decade from now, you're going to have millions of APIs which do machine learning on the cloud in the marketplace, and you wouldn't have to go and create custom things for yourself. You can just go and get an API, integrate that into your processes, do visualizations really without any custom data science or machine learning scenario. So we're not there yet. We don't have millions of APIs, but I think that's where the industry trends seem to be going. And this is some of the APIs now which are already in the marketplace you can go and start using right away. Facial recognition API, recommendation, speech, text analytics. This is all out of the box. You don't need data scientists to do this. You just go and start using it. Just to give you guys one example here, we took one of the facial recognition APIs. By the way, this is pretty sophisticated stuff coming out of Microsoft Research after 10 years of work. But now the API is there. And one of the guys on our team wanted to actually show a demo around it. And they created this site called howl.net. Basically, the idea is you go in, you load your picture, and tell you what your age is. It's supposed to be a demo to kind of illustrate what the power of APIs is and how you can quickly get things integrated. We showed the demo in Build conference, which is obviously one of our bigger conferences. The thing went viral. We had 80 million unique users loading pictures on it, 500 plus million images loaded in a matter of a couple of months. But and that wasn't even planned. It automatically scaled automatically on the cloud. We didn't plan for that kind of a viral hit, but when it happened, it just happened on the cloud. It scaled on the cloud automatically, and without really spending much time using data scientists, we were just using out-of-the-box APIs to do this kind of stuff. Okay, the last pillar which I initially talked about, which I want to mention here, is the third pillar. That's the second and the third pillar that's happening is on-premise and hybrid scenarios, and we're investing heavily into that as well. We bought this company called Revolution Analytics last year, and the way those things are getting integrated into products is that Revolution R Open, very similar to the open source R, is now called Microsoft R Open. The enterprise grade RE Revolution, the Scale R packages have been integrated into our SQL Server, so you can actually use R directly into the SQL Server. And as part of your stored procedures or T-SQL code that you're writing in SQL, you can actually execute R directly into the database without ever taking the data out of the database. So that's been the kind of the integration on the Windows side. And then we are also calling for Red Hat, Hadoop, Teradata, Microsoft R, where if you don't want to get in, if you're not doing it directly in the database, you can still run Microsoft R on many different platforms. And so that's the integration that's happened over the last year after the Revolution Analytics, which was high-performance R computing. Okay, so that's where I'll stop as far as the vision of what Microsoft's investing in. It went through a lot of material in a very short time, but I just wanted to give you guys some sense of the investments happening. Now I want to spend maybe a couple of minutes before I hand over to Ilan about the actual process of how we do data science what are the ingredients that we are finding which are common to almost everything? What are these successful ingredients? And I think I've kind of nailed it down to 4. These are pretty high-level ones, but I think if you don't have these in place, most of the pilots or advanced analytics projects that you want to do might end up failing. So the first one is that having a clear vision and purpose. So there is a tendency among data scientists, especially on my team for sure, and all the data scientists that I've ever seen, is this look at the data and start at the data level. They want to start exploring the data and figure out what can we do with this, right? And that's interesting, but a lot of times that can actually take you down into holes which you don't want to go down into, right? And if you don't have a clear use case, a clear purpose, and clearly aligned to your strategy of the organization, then you can actually spend a lot of time exploring stuff which is not very useful. So we often find people get really excited by data science and advanced analytics and have a lot of data, and they start using it. Eventually they have something that's useful, or they think that it's useful, and they go take it to their business stakeholders, and it's not really very interesting for them. And it doesn't move the needle on what they're trying to do. And the pilots just stop, and they don't go forward. So I think it's critical to make sure that that clear purpose and strategy alignment is in the organization, and you're trying to fully align your data around that. So that's one thing I think is pretty common in all successful pilots. The second thing that seems to also happen pretty consistently in successful pilots versus failed pilots is that there is a general cultural empowerment in the organization around data and data-related experiments and so on. And if you don't, if it's only a top-driven strategy where people at the top level, like CEO, is saying, hey, do advanced analytics, and it's not something that people feel empowered to do, or don't know how to do, or don't have the technology to do it, also can be pretty, not really go forward. So you can have a great strategy, but not a great culturally empowered organization, and it's going to fail. There's an anecdote I've seen where there was a research done, I think, at Penn State somewhere a while ago, where they said, how can we make kids eat peas, right? And they did a lot of research around it and said, can we give them incentives like ice creams to eat peas, or can we tell them to eat peas? And none of that works. The only thing that worked was you put them in a room of people who loved eating peas, kids who loved eating peas, and then the kid who doesn't like eating peas likes eating peas. So it's like, the cultural empowerment is like that. You need to actually put people into teams which like doing this, are data intense oriented stuff, and then the culture just spreads in the organization. The third thing, which I also find seems to tell us what is successful versus failure projects, is when someone comes and says we have a huge project. Almost a huge project never works. So almost always you want to start small and really want to iterate in data science projects. And most of the data science projects don't really you don't really know what you're going to find out. And so if you don't start small and you don't iterate quickly and fail quickly, you typically will end up into a kind of a wrong direction typically. So test the water, figure out the value, and iterate is the fastest way to do this. And the last one is collect the right data. So we have all of these things, and often I find people just don't have the right data. As an example, in predictive maintenance problems where you're trying to predict the propensity of equipment to fail, right? Now this is a big thing, by the way, in IoT scenarios. There's so many devices like elevators and grid meters and so on, and you want to predict them to fail, and people have a ton of sensor data, and they're all excited about it. They've got a petabyte of sensor data around it, but they don't actually collect failures. So how do you figure we are going to be able to predict the failure propensity if you don't collect failure data? So it's that kind of stuff where you have to think very carefully about what you're trying to do in advanced analytics. If you don't have the right data, you don't have it instrumented, you're not going to be able to do what you're trying to do. You could still do something useful maybe, but really maybe not what you were initially trying to do. So having those 4 things laid out puts the groundwork in for a more successful business transformation. So with that, I'm going to hand it over to Elon.
Thank you.
Yeah.
Okay, so I'm going to switch gears, and I'm going to talk about the process itself. So Pawan talked so far about what Microsoft is doing in this place, how Microsoft supports customers and use cases. What needs to happen in a company, the transformation that has to take place in order to start doing these things. And I want to put this framework around this because we are actually a team of data scientists, and we are working and we're seeing many customers over the time. I think we have covered so far a few tens or maybe hundreds of pilots, and we're running them simultaneously. And we had to come with a way to deal with them and reduce our fail rate. We don't want to fail after we spend 2 or 3 months on a project. So we really, after finding a framework, and what I'm going to show here is something that we have learned and we are applying. Obviously, we already we improving that all the time, and it is not guaranteed that everything will succeed, but it increases a lot the likelihood of successful pilots in advanced analytics. So the process has few goals, and if you read through that, it's pretty obvious, right? So we, first of all, we want to find opportunities. We really want to find those opportunities that will generate that business value, and it's all about business value. It's not about data, it's not about technology, it's about generating business value, and we really want to find those opportunities and constantly discover them and bring them up front and evaluate them, and which is number 2. We want to qualify and quantify those opportunities so we have a good way to assess whether we are on the right path or wrong path. We want to rapidly prototype so we can. Why? Because we want to fail fast. If something doesn't have a chance, I want to know it. I want to know it about a week later, and I don't want to spend extra cycles on that. I will just kill it as it is still small. So that's why we want to rapid prototyping. We want to, those that are already qualified and we prototype them and seems to be promising, we want to take them all the way through. We want to deploy them, and we want then to bring them to the point that we can generate the business value out of them and maximize that business value. So these are the goals. So the question is, how do we make that happen? So we came with this 4-step process, which has 4 phases. It starts with the business on the top right, a real good business problem that we want to solve. It obviously needs data, so we want to make sure that we have data. And there is a data science piece to that, and there is the business integration. These are all important. I will not have time to cover too many of the aspects here today, but I'll cover those that we think are most important. So on the business problem, there is a clear business need. Without that, we're not moving forward. We want to solve a real problem. It has to be measured. It has to have measurable outcomes. So if I cannot measure the business impact, I'm not going there. I'm not actually spending extra moment in beside trying to think, what am I trying to improve? What is the business metric I'm trying to impact? And then, like Parmeniv said, we want to make sure that we have the right data coming with that. So we are actually bringing right data and relevant data, and not something which is not relevant. The data science is a big thing. I'm not going to teach you data science here today, but I'm going to talk about how data science is coming together with the business to bring the value. And there should be a very strong collaboration between the data science and the business. In many cases, we see situations that the data scientists are going, they found a good problem to solve, they like working with data, and they're going to go and work on that stuff for a month or 2. They're coming back, and you don't understand what they've done there. I mean, why it's that is relevant. And it's really cool. It's really nice visualization. It's really, it's great looking. It's so cool that they would actually be smiling the whole time. But then when you try to understand how it's connected to the business, how it's solving the business, you have a hard time doing that. Sorry for that. No way to get rid of that. That was not the data science part. Okay, now maybe comes the most important part, and that is the integrated action. So Parmeniv talked about the action. We're doing that only so we can take action. And the action will generate the impact, right? So we want to make sure upfront, before we even started, that there is a way to act. And I'll talk about it more. And then we want to assess the impact, right? So let me put things in perspective, and I want to, my team is working a lot in the energy space. Sorry for that, it has its own mind. So I guess you can recognize what you're seeing here, right? Everyone can tell what they see? This is a wind turbine, and this thing is big. I'm not actually sure how tall it is, but it's really, really big. And there are many of them. And these turbines are generating energy, and it's very expensive to put them in place. And one thing that is important to the business is to make sure that this thing is operating all the time. When the wind is blowing, this thing is turning, and energy is produced, and revenues are coming in, right? If this thing is broken and is not working, we are losing revenues at the end of the day. And now this guy's up there. I'm not sure how he got there, but think about two things. One, it's costly to have someone up there. And the second thing, it's very scary to be up there. I'm not sure how he can actually cope with that. But so here is the business problem, right? So we want this thing to be up and running. So we are talking about uptime. Can we improve the uptime of those turbines so they can keep generating energy and we return our investment? So if I'm overlaying our process on top of this one for a moment, a clear business need, yes, we want to make sure these things are up, right? So we want to have a way to detect early problems and fix them before they cause this thing to stop, right? So it's what we call predictive maintenance, predicting when a problem may happen and take action before it happens. And thus we actually keeping these things working. Measurable outcome, yes, we want to improve our uptime by 30%, and we want to reduce our cost by 20%. We can really measure that. Business-driven data collection, yes, we want to collect data about failures. So these things have many sensors. So if you hear about IoT and so on, this is IoT. They have so many sensors installed in different parts of the thing, and they're also collecting sorry, it has its mind of its own. So this thing is, they have so many sensors, and they have also collecting data about failures. And when we merge these things together, we can build some nice things out of that. Data science and business collaboration. So when we come to the data scientists need to understand what they solve. So we need to translate that goals to them, and I'll talk about that in a moment. But not only that, the data scientists need to be fully engaged with the business problem. They need to understand that their goal is to make this thing working so they can detect problems earlier and so on. Integrated action is important, and also impact assessment. I'm going to talk a little bit about that more in the next slide. So don't get alarmed by this. This is putting together the process, and each of these steps that we've seen before has multiple internal steps. And I'm not going to cover everything now, and I'm not going to test you on that. But what is important to realize from this is that the business problem at the top there drives goals downward, right, toward the data science part and toward the data acquisition, so the data flow, right? So we have to flow data in all the time. And when we implement the stuff, we want to start integrating it back to the business, right? So this is the main idea of this slide. I'm going to drill a little bit down into each of these things for a few moments, so it will give you a better feel of what we're trying to do here. And again, I'll try to connect it to the wind turbine use case. I want to say at this point, it's just one use case, but you can have any use case in mind. It will still follow the same ideas, the same principles, right? You will still apply the same principle toward any other use case. So opportunity discovery. Here we want to ask questions that are kind of data-related questions. So we have data mindset, and we're going to ask questions like, how can we use data to increase revenues by X%? Can we predict which users are most likely to use our product? Think about your business. Can you think about questions that you may ask yourself if you had the data, would you be able to answer these questions? And if we take our turbines, the question was, someone asked the question, can we increase the turbine uptime? We really have problems. They are standing most of the time, or a lot of the time. Someone came and asked, can we increase the turbine using the data that we have from the sensors to increase the uptime by 20%? Someone else came back and said, yes, we can even do 30%, right? So this is a good example. So we're kind of generating these ideas, and now we want to qualify them. We have a backlog of ideas. Some of them probably have the potential, some of them may not, and we really want to make sure that we are able to find this quickly at the beginning. So there is a kind of a qualification checklist, and we really want to find out if there is a real business problem there, if there is a path to action, whether it's predictive use case or just an insight. Do we want the insight, or really want to predict something? Is it quantitative? Do we have the quantitative and qualitative metric in place? Do we have the data? Does the data fit? Is there ROI? If we check out all of these or most of these, it means that we may have a winner here, right? And then we can move on to the next step, and that is, let's formulate that. Let's make a clear statement about what we really want to do. In our case, we really want to increase the uptime by 20%, and the propensity to take, and we're going to calculate the propensity of a failure to happen, and if it's above a threshold, we're going to dispatch someone to that turbine. Maybe the most important part here is the last one, is the consumption scenarios. And if you do this part right, I think that you have done 80% of the qualification work. What we're really trying to do here is look into the future and say, if we had been able to solve that problem in a good way, how would we use that in our business today? So how would we integrate it back into our business? And this is a key question. It's not only technology, it's also a mindset. It's also teaching the people to use something new, which sometimes can be challenging. So in our case here with the turbines, what we're going to do, and we are kind of writing a script like a movie, right? We're writing a script that says, every day we're going to predict new failures. We're going to generate a repair list, which is prioritized by probability to fail or propensity to fail. We're going to set a threshold. Everything above that threshold, someone is going to be dispatched. We're going to dispatch the technician there. We're going to record the results, and we're going to retrain the model, right? And we know exactly how we're going to integrate our repair list into the dispatching system already. We have thought about it already. So it looks like we have a scenario that may work, right? And we really want to make sure we nail it up front. And if we do that correctly, we know already what to do after the data scientists are coming back and give us something that works. Still have some time. So I'm not going to dive into the data science here today. This by itself, how we do data science is an important question. But I do want to talk about the integration point. So when we start the data science process, we want to take the goal, the business goal, and translate that to something that we can actually use on the data science level. So here, for example, we want to talk about precision and recall. So these are terms, I'm not going to talk to you too much about those terms, but precision actually means that when we send a technician up there, it's better be a good reason for that, right? Because if we predict wrong and he went up there and almost got a heart attack because it's so high, he better had found some real problem out there to fix, right? So this is what we call precision. It's the true positive. There is real true positive in our prediction. Recall means among all the turbines that we have, we really want to find all the real problems and not leave anything behind, right? That is kind of recall, what recall means. And we want to give those numbers. We want to say, for example, 80% precision, 50% recall upfront based on the uptime that we want to achieve. Data flow, we want to bring the sensor data. Sensor data is big data. In this case, it doesn't have to be big data. In this case, it is big data. So we want to make sure that we have a way to bring the big data in and process it so we can use it for modeling. We want to have a good way for validation. So during when we model, we actually use historical data, historical failures, to try and some of that we keep out of the modeling process so we can use it for evaluation and see whether our model can really find those historical problems. So that validation takes place during the data science phase. And then when we deploy that, we want to tune it. So we tune it based on what technicians are actually telling us. They went all the way up there, did find a problem, did not find a problem. We want to take advantage of that and retrain our model. The business integration is the most important part. Again, remember the scenarios that we talked about a minute ago? This is where we make it happen. So we're going to integrate this into the repair. We're going to physically integrate it into the dispatching system. We're going to send technicians up there, and they will, we will compare their finding with what we predicted, so actual versus predicted, and we're going to actually make sense out of that and feed the feedback back to our model, back to our service. Then we launch it, and when we launch it, we really want to see the curve of the uptime going up, and hopefully it will go up. But everything has to come into place in order for that to happen. So I'm coming back to our circle, and I'm just putting together all the things that I just talked. I'm not going to repeat it, but you can actually see these are all these green boxes are along that path that we just discussed, and they are coming together around this cycle. And the more we go into this cycle, the better we learn, and we are becoming more proficient and more expert in doing less error and do the whole circle running much faster. So in summary, I think what we probably talked today and what I kind of illustrate here are maybe three things, maybe three takeaways. One is that is the reactive, moving from or transforming from reactive into proactive. So the turbine use case was really that, right? We don't want to wait until the turbine breaks. We want to reactively know that it's going to break and then replace a part or do something to prevent that. Historical data goes into predictions, right? So again, the turbine is a good example. We took sensor data, we built from historical data, we built a model, we took the patterns, we built a model, we can predict. In a moment, I'll let you ask questions. We generate the predictions from there, and now we're trying to put them into work. And then here's another important thing that we did not cover, but it's about automation. If we put human in the middle, the person will put their own judgment into this. And sometimes we want to avoid that, right? Sometimes we want the machine to give us the prediction that will automatically go and do something, and there is no human in the middle. These things are the real interesting stuff that you're going to see happening now. And if you come to us, you will see so many examples of that also in the work that we do. So this is what we had to say, and I think there are some questions, and we have a few moments for questions. Yes?
The historical data, let's say if your sensor has a 3 generation of version. Version 1 has 50% that generates bug. You fix the bugs in the sensor, you put sensor 2, it generates maybe 10% bugs now. You fix it, you have third generation, and when you come to the historical data, all those generations that you put in,
Yeah.
How do you think
Yeah.
some historical data can give you very, very bad picture, not even close to the reality?
Sure. So this is a good question. What happens if the data changes over time and we build our model based on one version of the data or schema of the data, and now the data change on us? Apparently, this is our life, right? So this,
Yeah.
this is what we have to deal with. And there are very many ways to deal with that. For example, you can build multiple models, right? So one model or services, one will work on an old version of the data, one on the new, et cetera, and then you can mix them together. You can actually take the output from a few models and do some weighting on that and make the decision based on that. You can do data transformation. There are so many ways to deal with that, but you know, I cannot think about any single pilot or use case that we had done recently that didn't have that problem. It's so common. Yep.
With the inventory of business problems that are identified, how do you vet them? Do you have an ROI process? How do you determine what to put your talented resources to work on?
Yeah, it's a great question. I was trying to touch that a bit when I showed the checklist of how you qualify. So I don't want to go back, but there is the slide that shows the first step of the business formulation. There is a qualification process that comes after the idea generation, right? So over there, there is a checklist, and we have this checklist. I mean, Palmolive is sitting in our triage, and
Who makes the decision?
Yeah, I mean, it's typically the business stakeholder that I think really has the best visibility into this, but it all goes down to the ROI that eventually will happen. And I think that the critical point is this last point here, decision automation and action. It's not good enough to say, hey, the criteria for this is, you know, can we get a precision of this and a recall of this, right? That's not your ROI, right? You have to really clearly look at, if you were able to do this, how that would impact the business, what would happen, what is that monetary value, what is the investment that needs to actually make it happen, and that's where, you know, you can make a more knowledgeable decision. But that's something that, you know, that's very, very centric to you know, that early part of the process. If you get that wrong, you may just go in a dark hole too. So.
Yeah, there is my answer to that is you should try to be consistent and follow the process and have an organized checklist. But there is a part which is also art to that, right? So there is the intuitive, the intuition and the sense, common sense that is there, and you developing it over time is also playing part of that. But I think that the more you're doing it methodically, the better you have, and you measure what you're doing, the better chances you have to succeed.
Yeah, the other thing I would mention is that the strategy of the organization is critical. Like sometimes people, you know, organizations don't have very clear strategies. And if you don't have that, then you have a problem, because not only for what you're trying to do in the data science, but you have a general problem. So if you have a very clear strategy, if you can map what you're trying to do in your data science very clearly back to the strategic goals of the organization, you are in a much better standpoint in making a successful pilot versus a data science project which you can't figure out, how does this go back to the strategy of my organization? If you're kind of ambiguous around that area, then there's a very large likelihood that eventually the pilot will happen, data science will happen, but from an execution standpoint, it won't really get integrated, because at some point, the CIO or some other manager will say, well, how does this really impact the business? How does this really change the strategy? And will get killed, right? So initially, that's why I was saying initially, you know, if you don't really, you know, strategy, having a clear purpose around the data science is like super critical, and we see that all the time. That a significant portion of the projects will fail if that strategy or the purpose of that organization is not well aligned with these data science related projects.